This video will provide an overview of installing a Rice Lake Weighing Systems Survivor OTR Series steel deck truck scale. The modular sections of the OTR Series truck scale are shipped pre-assembled and ready to be placed into position on temporary setting blocks using our crane. The general assembly order will be covered in this video, including setting the deck modules into position on setting blocks, installing load cell mounts in pockets and anchor bolts and base plates, running load cell wiring through conduit, and connecting the junction box and peripherals. Setting the deck modules. Deck modules are lifted using 4 chains or cables attached to the 4 lift lugs mounted on the top of the weigh bridge. The lift lugs provide balanced lifting of the modules. When the deck is level with the approaches, the finished scale has 5 3/4 inch clearance between the bottom of the weigh bridge and the concrete foundation. Most installers use setting blocks that are approximately 5.5 inches high for the initial placement and connecting the deck modules. Shims are used to level the scale and raise it flush with the approach bulkhead. Setting blocks are only used in the corner of the modules where the load cell mounts are installed. The corners that do not have load cell mount locations do not require setting blocks. Assembling the deck modules. Deck modules are designated as A, B, or C. All 2-module scales have an A and C module, while longer scales with more than 2 modules have 1 or more B modules. An A module is an end module and is the first to be placed on setting blocks. The left end is a straight end, which is positioned next to the vertical wall of the concrete approach. The right end of the A module contains 2 pin connection receptacles that are used to accept the 2 module support pins located on the B module. The B module is a center module and is similar in design to the A module, with the exception that it has 2 module support pins on the left end and 2 pin connection receptacles on the right end. The 2 module support pins of Module B are inserted into the 2 pin connection receptacles of Module A. Also, the pin connection receptacles of Module B accept the module support pins from a C module. The C module is also an end module and is the last one placed on setting blocks. The 2 module support pins are designed to attach to either an A module for a 2-module installation or to a B module for an installation that has more than 2 modules. The opposite end of the C module is a straight end and is positioned next to the vertical wall of the concrete approach. Raising and leveling with the approaches. Beginning at the left end of Module A, near the approach, raise the scale deck using low-profile hydraulic jacks. If necessary, add shims on the setting blocks until the deck surface is level with the approach. Move to the opposite end of Module A and raise and level this end. Raise, level, and shim all other installed modules. When all modules are leveled and shimmed, check the module support pins to see if they are firmly seated in the pin connection receptacles. The deck is now at its final position and ready for load cell mount installation. Load cell mount installation. Load cell mount components, including the base plate, mount blocks, anchor bolts, link, load cell, flex cable, and upper mount blocks, are shipped in the hardware box and need to be assembled while in the load cell pocket. To install the mount base plate and load cell in the load cell mount pockets, first remove load cell mount components from the packing box and position 1 set at each mount location. Working with the base plate first, lower the base plate through the load cell opening and onto the concrete foundation. Remove the cover plate from the 90-degree fitting included with the conduit assembly and insert the load cell cable through the fitting sticking through the area where the cover plate was. Thread the 90-degree fitting to the load cell, making sure the cable does not twist. Insert the cable through the second half of fitting and conduit, then reinstall the cover plate to the 90-degree fitting. Place the load cell link over the end of the cell and install the load cell link assembly onto the top of the base plate. Apply anti-seize compound to the threads of the load cell bolts before installing them. Torque the load cell bolts to 50 to 75 foot-pounds. Position the flex cable so that a loop can be made in it and the end can be attached to the rigid conduit. Mount block and shim installation. Apply anti-seize compound to the threads of the mount block bolts. Install one bolt through the welded block into the upper mount block. Install the second bolt through the blocks and shims, then torque to 55 foot-pounds. Repeat this process on all the load cell pockets. Recheck the link for any binding or misalignment and ensure that the link is plumb in respect to the upper mount blocks. Also check that the link is centered between the side of the link and the upper mount blocks. Jack the weigh module and remove the setting blocks. Slowly lower the weigh module until it rests on the load cell links. Use an industrial hammer drill to drill a 3/4 inch hole into the concrete at least 6 inches deep on one side of the base plate. Drill a second anchor bolt hole on the opposite side of the base plate. Each mount requires 2 anchor bolts to prevent longitudinal motion of the base plate. Insert bolts into the holes drilled into the foundation. Install one washer and one nut on each anchor bolt. Place a driver on top of the bolt and use it to seat the anchor bolts against the base plate. Tighten the anchor bolt nuts. Attach one end of the ground strap to the upper mount block. Insert a bolt through the wire terminal on the loose end and thread the bolt into the hole in the base plate. Tighten the bolt securely with a wrench. Load cell wiring. Electrical conduit is pre-installed at the factory and only needs to be connected between the modules and from the modules to the junction box. Following conduit work, load cell cables are routed through each conduit from the load cells to the junction box. Before the weigh module wiring can be completed, all load cell cables have to be routed through the conduit beginning at the load cell outlet. Before routing the load cell cables, mark each load cell cable at the end to help identify each load cell. Carefully make a loop in the flex conduit and position the end of the flex conduit close to the end of the rigid conduit. Working from the junction box end, insert a fish tape or similar tool and pull each load cell cable through the rigid conduit until all excess cable is taken in. When all load cell cable is pulled through, insert the end of the flex conduit over the end of the rigid conduit and tighten the fitting. When load cell wiring is complete, the wires will be connected to the appropriate terminals inside the junction box. Junction box connections. Each tough seal junction box contains a summing board with DC transient protection devices. A desiccant bag comes with the J-box and should be added to the J-box before final closure. In addition, a manual comes with the J-box for reference when trimming and calibrating. Connect all load cells to the summing board terminals in the J-box and connect the home run cable from the J-box to the indicator. Power up the indicator. Turn all load cell potentiometers in the J-box counterclockwise so all signals are at full strength. The first objective is to adjust individual load cells along one side of the scale for equal signal output when equal weight is put on those cells. Park the weight cart over each load cell on one side of the scale and record the indicator raw count reading. The lowest reading of the 4 cells is the reference cell. Use the cell potentiometers in the J-box to reduce the signals of the other 3 cells to match the reference cell. As adjustments are somewhat interactive, repeat the process until all 4 cells read within 0.1% of each other. Then repeat this process for the other 4 cells on side 2 of the scale. Now that all individual load cells are trimmed for equal output, pairs of cells on opposite sides of the scale must be trimmed for equal sectional output. This process is called section trimming. Follow the same type of process as used for the individual cells for the sections.